Hey, let's look at the last problem on the midterm 2 practice material. Evaluate the following showing your work. You should be able to do this without getting your calculator to do anything in scientific notation. Put your answer in scientific notation. So clearly this is going to be some kind of practice on performing operations on numbers in scientific notation and rounding appropriately. Remember that we have some slides that give you the algorithm for what to do when you are multiplying and dividing and what to do when you are adding and subtracting. Remember that those are two distinct algorithms, right? So I would definitely have that algorithm open when you are working through your second midterm. All right, let's look at the multiplication example. 2.36 times 10 to the 6 times 4.1 times 10 to the 10. Okay. So let's go through this set of steps. First step, put both numbers in scientific notation. Done and done. Coefficients between 1 and 10, coefficients between 1 and 10, power of 10, power of 10. These are in scientific notation already. Okay. Then rearrange the numbers you are working with. Okay. Remember that when you're multiplying and dividing, right, the operations are commutative, which means that I can just switch and move these around however I'd like, meaning I can put my two coefficients together and my two powers of 10 together. So let's go and do just that. 2.36 we'll still lead with here. And then the 4.1, don't know why I copied and pasted that, will be after that. And then we will put the powers of 10 together. 10 to the 6 and 10 to the 10. All right, excellent. All right, next we'll go ahead and multiply / divide. So here we're just going to do that piecewise. We will multiply our coefficients, multiply our powers of 10. So 2.36 times 4.1 should get us 9.676. And then for the power of 10, remember that when you have the same base, right, and you are multiplying, you want to be adding the exponents together. So this is going to be 10 raised to the 16th power. Okay, so we're almost done with this one. There's two more steps. Next, we need to put our final answer in scientific notation. Lucky for us, it already is, right? But if it weren't, we would need to. Then we're going to round. Remember that when we are multiplying and dividing, we want to round. We need to backtrack to the first instance where both of the numbers we are multiplying or dividing are in scientific notation. For us, that ends up being at the very start. They were already in scientific notation. We see that our first number went out to the 100th place. Our second number went out to the 10th place. So we are going to round to the 10th place because that is the less precise placement. So instead of 9.676, this will just be 9.7 times 10 to the 16th. And that's our final answer here. Let's look at the division one. For division, still going to be the same set of steps, right, as we did for multiplying. First step, make sure both of our numbers are already in scientific notation. This coefficient's between 1 and 10. This coefficient between 1 and 10. This is a power of 10. This is a power of 10. These are both already in scientific notation. Okay, so next step, let's rearrange these however is convenient for us. Namely, let's put the coefficients together and let's group the powers of 10 together. So let me insert a fraction. We'll go 7.34 on top, 2.116 on bottom, and then times another fraction, 10 to the -3 on top, 10 to the 5th on bottom. Again, this is all legal because multiplication and division are going to be commutative. We can rearrange these however we like. Okay? Now, we just have to perform these operations separately. 7.34 divided by 2.116. That's going to be 3.4 46880907 That's all my calculator will show me. That's probably all we're going to need, right? Because we're going to be rounding this at, in just a second, right? So just go as far as your calculator will let you go. Then times 10 to the, okay, we have 10 to the negative 3 divided by 10 to the 5th. Remember up here when we were multiplying the two numbers with the same base, we added the exponents. Since we're dividing two numbers with the same base, we're going to subtract the exponents. Negative 3 minus 5 should give us an exponent of negative 8. Okay. Last two steps, put your final answer in scientific notation. Fortunately, it already is. Right? This is between 1 and 10. This is a power of 10. Then round. I need to go back to the first instance where the numbers we were multiplying or dividing were in scientific notation. That's back here at the beginning. 7.34 goes out 2 places. 2.116 goes out 3 places after decimal. So we will round to 2 places after the decimal. We will round to 3.47. Okay, and that's our final answer. Okay, the next two are addition and then subtraction. Remember that we have a different set of steps for that. Fairly similar, but you definitely want to have this distinct algorithm pulled up when you're working on these problems. All right, but the first step is always, regardless of whether you're doing multiplication or division, first step is going to be put the numbers you're working with in scientific notation. Once again, lucky for us, they already are. Next step, we need to convert one of the numbers, the one with the smaller exponent, so that it has the same power of 10 as the other number. Remember that we're not allowed to just add 8.1 plus 7.21 because we have different powers of 10, right? In order to add these, we need the same power of 10. So we need to convert this 10 to the 8th to be in the form of 10 to the 9, right? And then adjust this coefficient accordingly. So we're going to leave this first number alone, right, because it's the one with the bigger exponent. And then this second number we're going to change. We need to have a 10 to the 9, and 7.21 is going to have to change a little bit. So I'm going to leave a little blank here for where the new version of 7.21 is going to go. We know that we want this 10 to the 8th to become a 10 to the 9. So let's go ahead and put that down as what we desire. So 10 to the 9. Okay, so let's figure out how we actually got to go to there, right? When we went from 10 to the 8th to 10 to the 9, we made this number, this exponent, 1 larger. That means we need to shift our decimal place over 1 in a way such that the new number is smaller than the old one, right? We went up by 1 on the exponent to make this overall 10 to the 8th be 10 to the 9th to make it larger. So we need to shift the decimal place over 1 to make this number smaller. To make the number smaller, we need to shift over 1 to the left. Right? So our new number that goes right here will be 0.721. Okay, notice that this is no longer in scientific notation. That's fine. We're going to have to briefly take one of these numbers out of scientific notation most of the time when we are adding. Okay, all right, so we have now made it so that these are the same power of 10. Now we can add, right, and that's going to be exactly the way that you would like it to be. Right? We can add the coefficients. We'll go 8.1 plus 0.721. Right? So 8.821, all right? And then we're still gonna have 10 to the 9th, right? We're not gonna add the exponents here, right? It's gonna stay as 10 to the 9th, just like when you are adding grams plus grams, it does not become grams squared or something, right? It stays grams, same idea here. All right, so that's fine, right? All right, excellent. Last two steps, right? So we want to add, subtract, then round. Notice that when we were doing our multiplication and dividing steps, we did our multiplying and dividing, then we put in scientific notation, then we rounded. For adding and subtracting, we actually round first and then put in scientific notation. All right, so first let's round. All right, so to round, we need to backtrack to the instance right before we were about to add these two numbers. So back here, right, when they had the same powers, this is what we're going to do our rounding based off of. This number goes out to 1 place after the decimal. This one goes out to 3 places after the decimal. So we're going to round to the less precise one. We're going to round to 1 place after the decimal. We will round to 8.8. And then last step, we need to put this in scientific notation, but lucky for us, it already is. Okay, so here's our final answer for the addition problem. And then last but not least, let's do the subtraction problem. 2.37 times 10 to the 12 minus 6.9 times 10 to the 3. First steps first, put both numbers in scientific notation. Remember, we cannot forget the step, even though none of these problems have required us to do any manipulation to put them in scientific notation initially, right? It could be that you are given numbers that are not in scientific notation, in which case you need to put them in scientific notation, okay? But like I said, these are not. So next step, these are not out of scientific notation. We don't have to do anything with them. So convert one of your numbers, the one that has the smaller exponent, so that it has the same power of 10 as the other number. So 10 to the 3 needs to become 10 to the 12. Right? So once again, we are going to leave this first number alone because it has the larger power of 10. And then we will subtract something, right? Basically the 6.9 is going to become a new coefficient. Right? And we want this 10 to the 3rd to now become 10 to the 12. Okay, now let's figure out what we needed to do in order to do this, right? I'm actually going to copy and paste this 6.9. Let's bring it down here, do some scratch work. So when we went from 10 to the 3rd to 10 to the 12, right, we increased the exponent here by 9 places. Right? That means that our decimal for the 6.9 needs to shift by 9 places. Right? To determine what direction it needs to shift, left to right, we need to see which direction is this exponent going. We went from 10 to the 3rd to 10 to the 12th, so we increased it by 9. That means we need to decrease this number when we move the decimal place. So we need to be moving our decimal to the left. And so I'm actually going to go ahead and add a bunch of zeros here, probably more than I need. Right? And let's count 9 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? That's where our decimal goes. I'll get rid of these extra zeros. And here is what our new number will be that goes in this blank up here. Not sure what happened there. I'm just going to write it manually. 0.0000000069. It's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and that should be a 9. Okay. Good. All right. So now we are actually ready to subtract this now very large looking number relative to this very tiny one. So 2.37 minus 0.0000000069 gets us 2.3699999993. Okay, excellent. All right, now what's our power of 10? This number times 10 to the, gonna still be 10 to the 12. Next step, we need to round, right? I need to go back to the instance where we were actually subtracting these two numbers, right? And round to the less precise of these. This one goes out to the hundredths place. This one goes out to well past the hundredths place. Right? So we're going to round to the hundredths place here, right? So instead of 2.369999993, we're going to go 2.37. Right, and then we need to put this number in scientific notation. Fortunately, it already is. Right, so this is our final answer. That might look a little bit strange because this number is actually the number we started with. Right? The reason for that is this 6.9 times 10 to the 3 is so much smaller than this number that basically when we subtracted this very small number from this incredibly large one, After we did that and then rounded, we basically just rounded so that we rounded back to this number. This number made such a small dent in this large number that when we rounded, it was like we never actually subtracted anything. Okay? That's not uncommon when you're doing operations with scientific notation. So that's our answer for the last one, and that's the last question on the practice midterm. Make sure that you are reaching out to me or to Professor Polito if you have any questions on these, and I will see y'all soon.